All right, welcome to the 11th annual Brew Robotics Club Challenge. 11 years ago, a group of us were meeting and we were lamenting the lack of robot building going on within the club. We noticed that building coincided with contests that we were having. We had contests including line following and maze busting and that kind of thing. But with contests, you always had winners and losers, and something wasn't always right. My tape was too shiny, my gate was too narrow, whatever. So we met at a library at the time, Castro Middle School Library, and we wanted to do something that involved little to no setup. And we met in the library, and there were all these tables around, and we thought, well, we'll put some nets under the table to catch the robot when it falls. No, that would involve setup. And that's when it was born, the TableBot. A TableBot is a robot designed to survive, live, and play on a table, or pay the price. So the end goal here, we want to be tabletop soccer. So how do you get there one step at a time? We decided to break it up into phases. And so since then we've had our June, August, and October meetings be phase 1, phase 2, phase 3. Phase 1 is to build a robot that simply goes from one end of the table to the other and back. Phase 2 is have it find a block on the table and push the block off. And phase 3 is to have it move the block into a shoebox mounted at the end of the table. We don't specify the size of the table, the color of the table, the size of the box, or anything. It's however you visualize it. We've had all kinds of crazy contraptions come up here and run this challenge since. We've had robot vacuum cleaning TableBots. We've had legged TableBots. We've had round TableBots. Just every shape, size, and variety. So without any further ado, I'll bring up one of my TableBots, and that is the Club Bug 1. Let's see if I can find it. Oh, it's over here. Hang on. So this guy, I'm just going to take this table here. Should be able to run it anywhere on any table. So I've got this table here, and let's see, Club Bug 1 do phase 1. That is, go from one end of the table to the other and back. Kind of exciting, huh?
Yeah. Very cool.
So can he make it back? We'll see. That Nat side here is robot's called Patience because it's really slow. Yay, phase 1. So this guy, he could actually do a phase 2 if I had a block. Let's see if I can get creative and find a block here. That's too high. Ooh, this is good. This will do nicely. Okay, so here's a block. I'll place it randomly. Yay! Phase 2. Okay, and phase 3, if I had a shoebox here, he'd push it into the shoebox. And let's see, I think I can demonstrate that here. This is kind of funny. This is a new trick I found with this robot. So I've got the bumpers. And notice when it gets the bumpers, he gets really pushy. He's trying to push, okay? But if you push something into the shoebox, that will detect and you can turn it to go away. Yay! Now how much would you pay? Thank you very much. All right. Do we have any other TableBots? Do we have any other TableBots this evening? Don't be shy. Raise your hand, Ralph.
All the people.
Come on down,
There's
Ralph.
at least 2 TableBots there.
Okay. Oh, I see Gil's over there.
TableBot.
All right. This is not a contest. It's a challenge. Flash photography is allowed.
So, some of you who've been here a few times would have seen MiniBot before. I'm just bringing him back because it's the annual challenge. So, he can do, technically he can do channels 1, 2, and 3. 2's a little iffy tonight because I just took him off the shelf yesterday and dusted him off. So, I will run 1. I think that will work at least, and then we'll see if 2 will work as well.
What could possibly go wrong? Are you starting it with remote control?
Yeah, so
Extra credit.
It has a remote control to choose. It's a standard video recorder remote control that you can choose which 1, 2, or 3 to run, or do it in manual. And the remote wasn't even working earlier, so we'll see if I can even get it started. There we go.
Yeah.
No hands.
Is it moving yet?
Oh yeah. So one thing I tried to do with this, he has 2 of the QRB11 sensors that are down facing on the front. And if one of them touches the edge first, it will back up, turn a known angle, and and go forward again, and using that it will try to triangulate what angle it came into the edge, and then it will correct itself and try to go parallel to the edges. If they both touch together, it will do a 90-degree turn because it will shoot at the square on. So there, as I said, it's a little out of whack, so it might get stuck in a corner right now, but it gets around this time. It's based on two layers, each has a pin. One does the motor controllers, and the other one does the navigation.
Nice sign on the display there.
Yeah, it's got a little bar graph coming back and forth.
Blinky lights.
So, I mean, it's very slow, but as you can see, it'll eventually work its way around. You don't have to.
So are you using IR to detect the edge?
Yeah, so it's using the IR sensor to detect the edge. Now I can just keep driving to the other end if we're patient enough to wait for it to go. So one of the wheels is walking, so it's not actually driving straight. It's here on the shelf. Now what we can do is stage 2.
Box. That phase 1?
So we'll call that phase 1. I think it'll take a long time to keep going. It's not in sync now, it'll just keep going around the edge until it gets back. So phase 2 is kind of limited and was only vaguely working last night. I actually used sonars to try to detect the ping pong ball, but that did not roll off the table.
You want to use the block?
No.
You got it? Okay.
And it's somewhat limited if it even works. It will try to locate the ball, and the sonars need adjustment, but ideally it will find that drive, and it has a little...
Take the video.
I should have, maybe I'll post one next time I actually get it to work.
We believe it.
So if the sonar detected something with the sonar, it would try to drive up, and it's got a little mechanical catheter that thinks it saw something there.
Sleight of hand. There it goes.
Come on, Betty Bud.
Now,
Come on,
right?
Betty Bud.
One of the wheels is walking, so it's going around in circles instead of straight. So
It's hard to...
we won't go for...
Okay, watch it.
It worked last night, sort of.
There's a lot of noise in here.
Oh, we've got these things
That
up there.
device right there outputs ultrasonic. So,
Oh.
I said, and these are my own,
Interferes with it?
yes.
That's the new my battery's low.
and these are actually my own sonar circuits. It's not like pings. I actually did the analog circuitry in myself. It's got 2 transmitters and 2 receivers, so it tries to actually get in the lips of where the object is, not just a range to it, so it can home in on it. But it was a good experiment at the time anyway, and I'll let somebody else come and do it.
Ralph Knock and the mini bot. Thank you very much. All right, who's next? Who else has a TableBot? Gil? TableBot? Come on down. So you can officially register. It's Gil Van Hoy. And your what's name?
Bob.
Bob. Gil Van Hoy and Bob.
Yeah, I want to, Gil is one of the members of the class that we've been running on the HP Robotics Club. So you'll see a lot of these robots made out of pegboard, a lot of similarity. These are all people who said they wanted to get started, so it's built out using an Arduino, some very common motors, and
Are those eyes stock?
the eyes are strictly his.
Bob's customized.
Okay, so I'll let Gil take over.
Unfortunately, it doesn't work quite right yet. But I'm learning a lot. That's the whole idea of the class. We've got motion. It's running on our Arduino with a couple sonar boards. It it's supposed to detect the edge. Unfortunately, I'm not getting a signal back from the sensors right now. But it does work. A little more learning and we'll be right there.
As camp, I think we need to move. So we did some testing in this room, and underneath each of these sensors there's ultrasonic interference. There's a dead zone right over here because the other sensor's right up there. So if we could ask, this might be okay.
Let's give it a try.
Yeah.
So a few people are going to have to wiggle around the beam here because we have problems with ultrasound in this room. Okay, you take it over.
All right. Thank you very much, Gil. Now you know we've got phase 2 and phase 3 of the HPRC challenge we do in August and October. These are opportunities for you to create and demonstrate what you've created. I think we have Alan Martinet here with the micro moves, right? All right, Alan. What's the micro moves going to do?
Well, it's been sleeping for the last year, so I really don't know what it's going to do, but I'm going to give it a try. That can be a goal. The box is a little light. I should put batteries in it, but well, first a little bit. It was built on the TableBot for about 2 years ago, I think. TableBot has got an Arduino in there, servo motors.
Which are the only two things we standardized on.
Yeah, that's all. And I elaborated a little bit to put some grippers in the
We
front.
elaborated a lot.
And a little bit. And there's about 6 different sonars. There's a bottom-looking sonar to find the table, and 2 to find the target, and 2 to find the goal. But it works, so I'll see if it's going to do anything at all here.
Micro moves, ladies and gentlemen.
So I'm going to go over here.
Will they fall off the table? No?
It should.
See, this was a silver medal winner at the Rebel Games 2 years ago, wasn't it?
Also won gold last year before last, so it's been around a little bit. It is running though, that's surprising.
Alan is surprised that it's running.
Well, I didn't test it, I just plugged it in.
Not so casual there. Oh! And it took up the fall. Can you complete phase 4? Phase 4, it's okay to take a fall, it just still needs to run when you put it on the table. This is the excitement of the TableBot challenge, ladies and gentlemen.
Somebody needs to stand here with a fish net.
No, that would be set up.
Of course, you'll be back here with the
TableBot survives, lives, and plays on the table, and pays the price.
Okay.
Is it running? Does it still run?
Yeah, probably.
The batteries did die.
What, does it run? Put it on the table, see if it does phase 4 here. Can I give you credit where
No
you
more
can?
floors.
Just a little bit.
My jaws are trying.
That's cool. Does it still run?
Don't run. It's like the sensor's not locked anymore. So the swivel gets.
Was that a joke there?
It's moving.
There you go.
All right, ladies and gentlemen, it's still moving. Phase 4. All right, don't push your luck now. All right, let's see. Victor.
Who's next?
Victor, right? All right, come on down. You see, Victor, one of the, what's it, infomaniacs we play so?
So this is okay, hello. Thank you.
Victor Lynn, right?
Yeah, thank you. So yeah, my
Another
name's
club bot.
yeah, my name's Victor Lim, and that's my wife Sandra over there. My son Michael, and my son Dominic. So we're fairly new members to the club. We joined maybe just a little over a year ago, and we were lucky enough to be able to join the class that Wayne offered. So he really put in a lot of time and effort.
Wayne Graham,
in the
ladies and
class.
gentlemen.
And also Chuck also assisted us, and Osman was also there, and other members. Yeah. So this is our robot. It's based off of the Arduino microcontroller, so we call it the Duinosaur. And we have completed phase 1, and we're working on phase 2. So I'll show phase 1, and if everything goes well, we'll try to show phase 2.
You gonna try phase 4?
Not yet.
I can't recommend it.
Nobody plans for phase 4. Hey, Alan, you might want to try yours again at this location. Oh, maybe too late.
Okay, so that's phase
Theater,
1.
dispenser, caster wheel?
Yep. Yeah, I heard that Wayne and Chuck actually spent the whole afternoon making these. So this is phase 1.
That's homebrew, man.
It'll take us a while to load phase 2, so maybe Alan, if you want to try yours again.
I was joking.
Oh, okay.
All right, do we have another TableBot? Do we have another TableBot while Victor loads up phase 2?
I see a hand going up there.
TableBot, come on down.
Come on
Looks
down.
like a Lego TableBot.
My name is Sarania, and I made this robot with my mom, and it does phase 1.
What's your robot's name?
We didn't give a name yet.
It's the Lego robot?
Yeah, it is.
That's good.
Mindstorm. So we're close to the edge, and there is a touch sensor there, and when it goes down, so the touch sensor is pressed, and so it backs up. And
I made this car with my mom, and it's supposed to grab the object.
yeah, so this is going to be the second phase to grab the object and then push it. It's still in the working phase. So this just we're building it separately, and then it's going to get connected and. So that's pretty much it right now.
Right, thank you very much.
Thank you.
Victor's
So,
gonna come back.
Victor, are you ready with phase 2?
Yeah.
All right.
Okay, so
Arduinosaurus, phase 2.
I'm wondering if you can fix that.
Go.
If there are any small children in back, they're welcome to come forward to get a better view. We've got some chairs in front
This is
here.
it. Yeah.
Phase 2. One more time.
One more time.
One more time.
Is it once enough?
Never enough.
All right.
That's our new storage, phase 2. Who's next?
Excellent.
All right.
You should tell them how many sensors you've got and things like that.
Oh, okay, so for phase 2, we're only using 3 sensors. So the 2 edge sensors that we use for phase 1 and this middle one that we're using to sense the object. So these other 2 sensors are for phase 3 to sense the goal.
And you also had something to do with the t-shirt
Oh.
that I'm wearing, right?
Yeah.
Did you?
Yes.
So Victor was the designer of the logo for the club logo. He was the winner of the contest last year. As a reminder, we do have t-shirts available if you go to cafepress.com. Thanks again.
Thank you.
There we go. We never miss an opportunity on t-shirts there. Our treasurer, ladies and gentlemen. Is Orion ready? All right, come on down. Orion Willie and his Bobot. What's your robot's name, Orion? Oh, you haven't named it yet? Can you show the folks what it does? You want to hold the microphone? Okay, tell them about your robot, okay? Look out there and tell them about your robot.
So I made this robot with my mom, and
Julie Willie, ladies and gentlemen.
and now I haven't quite got to do rather than move around, so it won't exactly stop when it gets to the edge of the table, except for it will go to it. Except for that's one problem, because it'll probably fall.
What kind of chip does that robot use?
It uses Parallax.
Parallax chip? What about those commands? You know the commands?
Yeah.
Okay.
Program
Are we going to see it run?
Oh, there it goes.
I forgot that was the number.
So you got output there and you're trying to get input, right? All right? Your robot has output, that is the motor's moved, and you're going to be working on some input so that it can sense the edge of the table and bumps and stuff, right? Is that what you're going to bring back in August?
When we get to come.
We'll see. Okay, very good. Thank you very much. Orion Willie, ladies and gentlemen. Letting young roboticists there. Who else has a TableBot here? TableBots. Last call for TableBots. TableBot, last call, going once, going twice. We're going to be moving into the run what you brung category. This is kind of a catch-all. The first year we did the TableBot challenge, it was all great. But, you know, it's like, there's a lot more to this than just tabletop robots, so we opened it up. And the concept is you to bring your robot in some state of finished in June and then enunciate what your phase 2 and 3 goals are. It doesn't always work out that way. In fact, it never works out that way. We usually show up in June with a pile of parts that sits here and you enunciate your phase 2 and 3 goals for August and October, and hopefully by October you have it moving around and doing what you expected it to be doing in June. But regardless, that's why we have these challenge meetings as an opportunity to, or it's a deadline that forces you to create. Without a deadline, nothing happens. So, run what you brung. I guess I brung one that I like. It happens to be one of my personal favorites. Hang on one second. Can I get you to hold this? All right, this is, hello, this is Rocky. Rocky, the robot pirate. All right, kitties, no. All right, avast ye scurvy swabs, prepare to be boarded. All right, I'm going to be working on my pirate voice. Anyways, I tried to bring him out and tried to get his arms at some kind of level, you know, to serve trade, to serve food. But that didn't work out well at all. Anyways, so it's a nice universal robot. For Christmas, he's like the Santa bot, and it's really fun for Halloween. I think some of you know my other robots, including Scully and the Crow and so forth. I resisted the temptation to bring him this evening. In fact, I was limited in my ability to bring her. But regardless, this is Rocky, his wife. It's actually built by John and John Erickson and Carlini. Erickson, Carlini, you want to bring up Charlene and the Zybot? They're kind of a team. They're known as the Black Mask Dancers. We performed with a rock band called Black Mask. We used to perform with them anyways. I think we got kicked out of the band. We'll see how it turns out. People were complaining. Are you guys coming? All right. So we'll save our rock rendition for October. Thank you. So these are like full-size robots. Actually, recently in the month of March, we took the 3 robots up and down University Avenue, a total of over 2 miles. We called it the University Avenue Death March. But all the robots, we made it, actually, this was the Zybot and Rocky, drove over 2 miles all the way up and down University Avenue. All right, guys, let's just move them around a little bit. Yeah, that's what they were complaining about. Yeah, similar. Yeah, actually it's the same. This is a drive system from Herbach and Raven. It's really an excellent gear system. I like it for the arms too. On Rocky, for example, you know, I just power that with the servo and single pole or snap action switches, one direction, the other direction, up and down. But I just power it with like 2 9-volt batteries. So, you know, if you're here like that, you know, it's not going to burn out the motor or anything. It's not going to take anybody's head off. You know, it's compliant, as they say. So that's the Zybot, Charlene, and Rocky. I think Zybot has a special talent. Question?
Just a quick question. How much can it lift?
It's looking like almost 3 pounds.
Zybot's the strong man of the group, and we have a we have an exercise. I'm going to show you strengths of power of the Zybot, right?
Right.
Who does that?
We're charging it a ton.
Normally we would bring a 3-pound weight. We didn't bring it today, but it'll lift 3 pounds. It'll actually lift a little bit more than that, but you know, for safety concerns, we only say about 3 pounds. Arm goes up and down. That's about all it really does. It can spin. I can tell you, hopefully if everything works out right, I'll be around the corner and I'll pick up a can, but I don't know if it'll work or not as far as...
Where's the prop?
You know, but I want to do that like a little bit of ways away.
Well, where's the prop? We can do it right here. You got it? People came for a show.
Don't let them down.
That's right. People pay good money to get in here, right, Austin?
Yeah.
How we doing?
He's going to go like face this way and then try to pick up the bottom.
These guys are gonna get fancy now. You got telepresence? How's that working out for you? Looks pretty shaky. Regardless, the man behind the curtain is gonna grab something. We'll see how this works. Working without a net here, folks.
Special prop.
All right.
Definitely it'll work.
No, it still don't hurt anybody. Just put it over here.
Jacob here? All right. Carlini is looking the opposite direction through a video on the robot. Here the Zybot is approaching the bottle prop.
Robot bottle.
What the robot bottle, thank you.
It was not easy to find it.
Not easy to find the robot bottle. Not talking about you.
We know.
Careful, folks. get the camera. There we go. Oh, no, he's getting lined up.
No, I don't know. It's battery's died. No,
It's the ultrasonic emitters.
Hey, don't mind.
All right, all right.
there are many obstacles.
Hang in there, folks. The Zybot approaches the problem.
Oh, yeah. Perfect, right there.
Can he do it? The video looks really shaky.
You got it, you got it. There you go. He'll get
It
it.
looks like he's lined up, folks. He's adjusting the grip.
Oh, yeah. Oh, yeah.
Straight on.
He gripped too soon.
You're too tight, man. Open up.
Thought he had it too soon.
You're gonna have to get it deeper. Yeah, but you're pushing it. You're just your hands.
So this is the next step on the beam, right?
Alright, well. And if you push it too far, then you run out of range. You try it, man.
There we go. Try.
Okay, now you're on the edge.
One more try. No pressure, Carly.
I know. Is my hand open yet?
No. Opening.
Yeah, but I can't see you there. Alright.
And there you are. You're fully open now.
Camera's mounted in the gripper there. Come over here and drive it in and pick it up, Darlene.
Yeah. Alright, we got told out too much.
Turn it around. There we go. Turn it around. Ladies and gentlemen, the sideline. Thank you very much. All right, run what you brung category. Who else has a homebrew robot? Maxim Bravo and the Mighty Eagle, a bronze medal winner, Robo Magellan at Robo Games 2013. I think you got like 6 or 8 feet from the goal, didn't you? Well, pure GPS.
Okay, so this isn't actually the robot that won the bronze medal, but this is the second version of the Mighty Eagle robot. So
Don't mind me, don't mind.
we had a few changes in the wheel, the configuration of the wheel we changed. Yeah, and instead of having motors in the wheel, we now have this Lego motor from Challenger. The output of the cable output was a very weird output that did not fit in any of our ports. So we opened up the motor and soldered it. So now now it works just fine, but we don't really have a program to run it, so it doesn't work, but it did work.
Well, thank you for bringing this in. What are we going to see the Is this Mighty Eagle 2?
Yeah.
Mighty Eagle 2, what do we expect to see Mighty Eagle 2 do in August?
Rock.
Move?
Yeah.
That's a good starting place.
Obviously.
Okay. Maybe the FloorBot challenge.
Yeah, maybe. But yeah, so these motors spin and then it touches with these wheels, so the wheels move and the robot moves.
The Mighty Eagle 2 will be back in August and October. We'll be moving. Hey Tony, how you doing? All right, what else we got for Run What You Brung? Steve, come on down. You usually have a Robo Magellan robot, right? Poke salad, Annie, something? Salad? Potato salad.
It's not
No? How's that? Okay. I'm going to have to get this started right away because it's so slow that I'm going to be able to describe it by the time it's done. This is intended to be part of the firefighter at next Robo Games. What it has right now is a propeller board, and it has a bulb that detects flame. So there's a little shutter here where it turns around and locates the flame and then goes forward. There's going to be a propeller at the end of that motor to blow the flame out. And in addition, I have an ultrasonic sensor to be sure I don't run it over. And there's going to be 5 more sensors to navigate through the walls of the maze. And that's about it.
Steve, what is your robot's name?
Little Chris.
Little Chris.
Yeah, my brother-in-law's a firefighter, so, and that's about it.
So this will be a firefighting robot, right? For Robo Games? All right, very fine. Thank you very much. Steve Joyce, ladies and gentlemen. All right, Run What You Brung. Ralph Knock, ladies and gentlemen. Probably the only guy who has almost as many robots as I do.
Three working robots
With
tonight.
this balancing robot named Balancer.
This is a balancer, nothing particularly.
Oh yeah. Da, 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 da. Yeah, he's not nervous. There it goes. Can you do the TableBot challenge with it?
I mean, it's remote control, but yes.
There's no rules against remote control. It's frowned upon, but I rule against it. No robot that goes from one end of the table to the other and back.
It is under.
Whoa, see, isn't that exciting?
It is under remote control, but just to show that it can be guided as a balancer. My Xbox batteries are running out, so it keeps losing the
That's what
control.
I'll say. It's not that, it's the UI. Hey! Yeah, Ralph covered 2 categories at once, Run What You Run, and Table, 3 categories, and Balancer.
And there'll be a FloorBot to show as well.
Yeah, FloorBot, oh man, going for a triple play.
There we go.
Awesome, thank you very much. Ralph Knock, ladies and gentlemen. All right, who else brought a homebrew robot this evening? All right, come on now. What's your name?
Let me give you this instead, okay?
What's your name?
Sylvia.
Sylvia?
Me and my dad built this robot. It's from the robot class, and this has the Arduino Uno, and then it's supposed to run, and when the sensor senses an obstacle, it's supposed to turn around and go.
Is it running this evening?
Yeah.
Well, let's see it run.
This is a
Wise man
FloorBot.
doesn't run it on the table. It's a FloorBot, ladies and gentlemen.
So,
Why don't you put it up on the table so folks can see it? Just make sure it doesn't fall off. We'll even give you credit for doing the TableBot. You know?
Google has provided us an obstacle to avoid.
Don't let him back off the table. Let him run down the table a bit. Yeah, let him run on the table. Watch out.
Let me run down the table.
There you go.
Here we go.
All right. You're easily amused. I'm sorry, your first name again, 7? Your first name? Sylvia? All right, Sylvia, thank you very much. With another HPRC Club Robot 2013.
Yes.
Thank you very much, Sylvia.
I should mention that the first set of classes for the Club Robot are officially over. We're preparing for the next round of classes where we're going to try and put basically a Raspberry Pi on each of these robots. It's actually, the Wi-Fi is causing us some problems, so we're still trying to make sure we've got one that works before we replicate it onto a bunch of these ones. So watch this space. Hopefully we can have something by August to show you some Raspberry Pi-based robots.
Say, Mark.
Okay, thank you.
You want to go next, Mark? Okay. Mark and Maxwell. Maxwell, the creepy humanoid-looking robot. Really awesome. I mean that in the best way.
Let the guy in the beam robot get closer.
Yeah, very kind, very kind. See if he's still running. Okay, so his name is Maxwell. He's an humanoid android head. I designed him as a platform to experiment with human-robot interaction. The first program I did for him, he has motors to move the eyes, a motor to move the jaw, and 2 motors to move the head around. The first program I built for him was an animatronic control program, so you could make the head move around, puppet the head around, and so on. And you could type things into the control program for him to say. Or, because I was a slow typer, I added some hot buttons onto my joystick because the joystick had all these cool fire buttons. So I figured, what could I use them for? So they're all macros for him to say canned things like, and perhaps if he was laughing. Let's see what else. Yeah, stating the obvious. So that's the animatronic control program. You can see it over there. So when he's doing the speech, the program that's running him, written in Visual Basic, is taking the.
Hello, my name is Maxwell.
Nice. So the.
I don't feel so good.
You can also slow him down so he sounds like he really doesn't feel very good.
I don't feel so good.
How about a not?
I don't feel so good.
Excellent. So when he's doing the speech synthesis, the program that I wrote in Visual Basic is as the speech synthesis program is running and sending the sounds out to the sound card, the phonemes are getting picked up, goes through a lookup table, and uses that to identify what position to move the jaw to, so the jaw goes to the appropriate point for the sound that he's sending out. Unlike older systems that use just say the volume of the sound, which wouldn't be quite correct. So this is the animatronic one, and then I added a webcam into his forehead there. So with the webcam in his forehead, I switched to a different programming language, something called processing, which is a Java-based programming environment, very similar to the Arduino. So with this, he's looking for a face in the frame of the webcam. As soon as he picks one up, like Gil, he immediately tries to move the head to keep the face he detects in center. He lights up his eyes and opens his mouth when he sees a face to sort of show a sign of recognition, like, oh, I see a person. His eyes have red, green, and blue LEDs installed, but I did the blue lights for when he's seeing a person because I thought that was a little bit friendlier. The face I sculpted and made my own vacuum forming table so I can make the faces out of plastic. See if I'll pull his face off while he's running here. So under the face, you can see the eyeballs, and of course the webcam is much more obvious. It looks kind of funny with just eyeballs and a jaw moving. It doesn't really look like a head. But once you have the face and the eyes in context together, then immediately you recognize, oh, that's a face, no problem. The wood parts are all laser cut plywood. There's several circuit boards running him. There's a circuit board to run the LEDs, and there's a circuit board servo controller on the back of his neck. They both connect over a USB back to the PC, which is down here in the torso. Theoretically, if I actually got my act together, I could redo some of the electronics and squeeze them all back into the torso instead of having the wire salad. I have a constant wire salad battle with various things of electronics that always seem to hang out the back of it. So that's been a long-running source of pain and frustration, and I have some ideas on how to fix that, which hopefully I'll get together in the next few months. Yes, that's cool. The one last thing. When he's doing the face detection, he's moving relatively slowly. I slow down the servo controller slightly. The PC and the torso that does the face detection does it okay, but it's not terribly fast. It's anywhere from 3 to 5 frames per second, more or less, which is okay. It's you can demo it and see, yes, it recognizes the face. But when I first built the face detection thing, it was for an art show, and he was hanging upside down in the window facing the sidewalk in downtown Portland, Oregon, which was great. But when people would walk down the sidewalk, when you're walking at sidewalk speeds and you glance away, that's not enough time for him to analyze the whole frame and pick up that was a face and do his whole lights and an open mouth and all the good stuff. So I was sorely disappointed. If they do the double take and give a little bit longer, then it was fine, it was perfect. And thankfully a lot of people, when they see a robot hanging upside down in a window, they double take as they walk by. But I do have some plans in place which I couldn't quite get working for today, which hopefully will be working for August or
August
September.
and October.
To speed that up a little bit, I found out and have proven that if you add in a graphics processor of some kind, you can spread the task out over multiple cores, and now you can achieve 10, 15, or more frames per second of face detection, which is much better for sidewalk, single glance type action. Thank you.
Thank you very much. Thank you very much, Mark. Maxwell. Next we have Emil Mehta and his guidance stick.
Okay, so today I'm going to briefly explain this idea. I got here from last month when I came here for the robotics meeting. It was a man had made this device that you go from point A to point B. But however, there was, but what's different from his idea to mine was that his prototype had a chassis attached to it, but mine will just be a smart stick. So what my prototype is a smart stick that when the blind uses it, when they move the stick from side to side, the sensors on the stick can detect different moving and non-moving objects to guide the blind out of its path. So yeah, unfortunately I don't have a working prototype yet. I'm still working on it, and hopefully I'll have something to show for next meeting next month. So the basic function of the stick was to let the blind know ahead of time objects that they're about to encounter. And future models of this device would include finding routes from point A to point B, whether there was an incline or a decline around the blind person. Like suppose you're about to step off a curb, it would say going down 6 inches or however high the curb was. And also it would also tell where the blind person was near via GPS. For example, if the blind person was near the Eiffel Tower, it would say that, or I don't know, something like that. And also, one of the more complicated future models that I'd like to be developing would be an AI networking system where the device would automatically classify on its own and learn whether an object was moving or not moving. Okay, so there were 2 main components to this design. So I'm going to talk about the design of the body. So the design is going to be like foldable, and yeah, so there's going to be a stereo system embedded in the stick, and it'll make a noise depending upon the distance of an object. For example, if the distance of an object in front of me, suppose it was this chair, maybe about 2 feet, it made a higher noise than, a louder noise than, suppose, this bat. I don't know. It'd have a higher noise than something a little bit farther away, so it would alert the blind that how far away the object was, and it would also make a different noise depending upon the object was moving or not. So suppose the object was moving, this chair is obviously not moving, so it would make a barking noise for all non-moving objects, and maybe a ringtone noise for all moving objects. And so the sensors I used to make this, the design of the design of the body would be several IR sensors at different heights to detect different objects at different heights, and also ping sensors to detect how far away an object was. And the body would be made of aluminum. So the design of the handle would be divided into 2 components. So either side would have separate buzzers embedded on each side, and each buzzer would correspond to which direction the blind person would have to move. For example, if I was moving towards an object, and the device would want you to move to the right, on the handle there'd be 2 different buzzers, one on the right and one on the left. And if you wanted to move on the right buzzer would buzz, and depending on how hard the buzz was, you'd move to the side that much, and yeah. So the specific parts I need to make this design: 9-volt battery pack, rechargeable piezo pulse buzzer, piezo speaker, 3-axis accelerometer, and IR sensor. And as you can see from the IR sensor and the 3-axis accelerometer, they're fairly small, which would fit into my design. But yeah, we might have to redesign the Arduino board so that it could fit within the limits of how big the stick would be. So software and the platform. So the platform I'd use for this design would be Arduino, and we'd be coding in C++. And also, yeah, that's it. Thank you very much.
Thank you very much. Amal Mehta.
Very good.
Something like this, one of the best things about robotics is the application for disabled, and for that matter, in the future, we'll all not only want our robots, we'll need them. Question?
I just wanted to make a suggestion. I work with aluminum. If you wanted to fit the microcontroller in, you could make it a tapered shape, and you can make it wider at the top, and make it like a teardrop taper shaped stick instead of a straight stick.
Are you up next?
To give you more room on the top.
All right. All right. Thank you very much, Emil. Thank you.